Hello all, as a continuation of my lecture series of special electrical machines, we are discussing about other motors, and here we are discussing about linear induction motor. In previous video we have discussed about the introduction, construction and working, whereas in this video we will discuss about the advantages, disadvantages, and we will elaborate the working of the linear induction motor. So this linear induction motor, it is based on the principle of electromagnetic induction. When an alternating current passes through the windings of a primary, it creates a moving magnetic field along the motor's length. This moving magnetic field induces the eddy currents in the secondary, which is typically a conducive plate made of aluminum or copper. These eddy currents generate their own magnetic field which interacts with the original field from the stator. The resulting force propels the secondary in a straight line, creating the linear motion characteristics of linear induction motors. The speed and direction of this linear motor can be controlled by adjusting the frequency and phase of the input AC power, allowing linear induction motors to be highly efficient for direct linear operations such as transportation and conveyor systems. So, coming to advantages and disadvantages. Advantages: reliable performance, precise control, direct linear motion, low maintenance and smooth operation. These all comes under advantages of linear induction motor. Whereas in all the components or electronic equipments, we have either both advantages and disadvantages. So coming to disadvantages: limited speed range, so that it can operate with a particular speed range only, so it cannot be used for high speed applications. So the efficiency is low and high power consumption, so the consumption of power is very high. Complex control system, so if we want to give any feedback or if we want to control the speed of the motor, then it is complex and it is of high cost. So this is about advantages and disadvantages of linear induction motor. Coming to applications of linear induction motor, so maglev trains, roller coaster and elevators are the main three applications. Linear induction motors are the primary propulsion system in magnetic leviation trains, allowing for high speed travel without contact with the tracks, so resulting in reduced friction and noise. Coming to roller coaster, many thrill rides use linear induction motors for rapid acceleration. So we all would have experienced a roller coaster, so in which they are using linear induction motors. Coming to elevators, linear induction motor technology can enhance the efficiency and speed of the elevator systems, particularly in high-rise buildings. Okay. So in this video, we have clearly discussed about the working and advantages, disadvantages and applications of linear induction motors. And with this we are going to come to the conclusion of the subject special electrical machines, where we have discussed many things about the special electrical machines, particularly about permanent magnet brushless DC motor, its construction, operation, torque equations and controllers like microprocessor based control circuits. And coming to stepper motor, we have discussed about many drive circuits and the usage of drive circuits. So without the drive, the stepper motor cannot operate. And coming to switched reluctance motor, construction and operation, torque equation, controllers, all those were discussed. So in this lecture series, I would tell that I have got many and more experience, we learned in depth about each and every motors, and along with the torque equations, and we have solved many problems using equations and EMF equations also. So EMF equations, and so these equations are the important thing where we can plan for which motor can be used for what particular application based on the torque and the EMF. So I thank everyone for watching my videos, and I conclude that with this the lecture series of special electrical machines, and we will be seeing and with the new topics in the upcoming videos. So uh, thank you.